So I'd now like to transition to today's main event, Dr. LeDell's keynote. Dr. Erin LeDell is the Chief Machine Learning Scientist at H2O.ai, the company that produces the open source distributed machine learning platform H2O. At H2O.ai, she leads the development of the H2O Auto ML algorithm. She is also the founder of Women Machine Learning and Data Science and co-founder of Our Ladies Global. JuliaCon has a long-standing tradition of reaching out to incredibly talented individuals in many other programming language communities. As Uncle Iro said, it's important to draw wisdom from many different places. If you take it from only one place, it becomes rigid and stale. We're lucky to have Dr. LeDell with us today, so please join me in welcoming her to the Julia community. Please remember to ask your questions via the Pigeonhole link or in the green channel on Discord. We will monitor them and raise them at the end of the talk. Dr. LeDell, we're ready for you now.
Okay, let me make my screen full. Hopefully you can see my screen. So yeah, thanks for having me at JuliaCon. This would be actually my first JuliaCon. I'm very excited to participate. So today I'm going to, and by the way, if you hear a little bit of whining in the background, that's my dog. Hopefully he's behaves himself well during this talk. The title of my talk today is APIs and Community, Building for Success. So kind of the goal of this talk is to, I'm coming generally from, I consider myself part of another language community. I'm more in the R and Python community, although I will talk a little bit about my history with Julia. And so I think my goal today is to draw on some of the things I see as successful trends in the other language communities, and hopefully you can, I know Julia is doing a lot of these things already, but I'm going to highlight some of the things that I think are important for success of a language and just generally success of like any open source tool itself. So so yeah, the talk is divided up into a couple different sections. So first, I'm just going to give a little bit of an introduction because most of you may not know who I am if I'm kind of coming from an outside community. So I'll give you a little introduction of my background. Then I'll talk a little bit about the kind of language wars thing that happened sort of in the R and the versus Python communities. So that I would say that's mostly a thing of the past, but I'm just going to sort of highlight that as something to kind of avoid as we enter like another language that is kind of similar to these other two, at least in the machine learning and data science space. I'm going to talk a little bit just about the history of languages as interfaces, specifically to other languages and tools. And then I'm going to talk about multi-language software stacks. So that's one of my focuses at H2O, which is a multi-language software stack. I'm going to talk a little bit about why I think APIs are more important than benchmarks. So just the general experience that you have with a language or with a tool is, primarily focused on the API experience. And then lastly, I'm going to touch on community, which I think is a hugely impactful piece of any software package or language and their success. Okay, so why am I here? So that was kind of a question I had when I was invited to speak, because I'm not a big person in the Julia community, so I was wondering myself, why am I invited to speak at this talk? So I guess this is a tradition of inviting people outside the Julia community, but I have some experience with Julia, so I have used Julia. Almost 8 years ago, 9 years ago now. I first encountered Julia in grad school, and I kind of immediately loved it, and and this was also after working with some other languages like C++. and also Python and R, and, really when you're in grad school, when you're doing research and you're, under a lot of time pressures and other things, like you really want to be efficient with your programming languages, especially if that's kind of the focus of your research. So to me, it was immediately like, oh, this makes a lot of sense. I see why they want to build this. I like it, and I want this to become the new Python or the new R. So that was, kind of my initial experience with Julia, which I'm sure a lot of people here can relate to. So just a little bit about my other background. So I'm quite involved in the Python and R machine learning communities. I guess especially R, but also Python as well. I have kind of a history of writing machine learning packages in mostly R. I do some work in Python as well related to benchmarking. And yeah, I mean, now I work as the chief machine learning scientist at H2O AI. And so I'll say a little bit more about what that is later, but we are a multi-language tool. So we have a Python API and an R API. And I work in both of those languages regularly. Also, I have a long history of community organizing. I've been organizing meetups for over 10 years in the machine learning community. And I think was one of the organizers of I don't know if it's the first machine learning meetup ever, but one of the first ever meetups in San Francisco was a small machine learning group back in like 2008. So yeah, I've always kind of been a community organizer, and it's something I really enjoy. And I will also talk more about that later. Okay, so I mentioned that I have worked with Julia before and kind of came into it like probably a lot of you do, either through grad school or some other experience where you're kind of, in a very investigatory phase of your life, trying lots of new things. I think recently, I don't know if this was before or after, I think it was before I discovered Julia, had taken a computer science course. My background is statistics, but I also took computer science courses in grad school. And so I took this C++ course for machine learning, basically. And I mean, it was really quite painful. I'll just be brutally honest. It was really hard, especially coming, I'm a statistician. I'm not a computer scientist. So I'm coming from a background of, languages like R and Python, and it's a whole nother level of thinking that has to happen on top of just writing code that makes sense. So it's hard. And the goal, I think in me learning that at the time was I wanted to find out how to write algorithms that would be fast. Because I did understand there were limitations in like native R and Python in terms of what you could do with speed. I think also around the same time, I worked at a startup that was building a very fast random forest implementation in C++. It was an old startup called Wise.io that doesn't exist anymore. But basically, I saw also, wow, they're able to make this extremely fast implementation of random forest with like a really, really low memory compared to what else was out there for random forest at the time. So this is also like early 2010s when people were more excited about things like random forest and not deep learning. So anyway, for me, it was really like a dream come true. I thought it was amazing. The code that I wrote was highly parallelized. So I just remember learning how to make something parallel and just sort of, it was just trivial, really. Like you just, there's no learning about all the different ways of parallelizing things. R in particular, especially at that time, had like several different ways for parallelizing things. Python also does as well. But one of the things I first ran into, of course, at this time of like 2013, the machine learning ecosystem was very immature. I remember the first kind of roadblock that I got to was I had discovered the GLMNet package. So thank you to Simon who made that, which is basically a wrapper to the Fortran code that is also in the R GLMNet package. So I discovered that package. It was something I was familiar with from R. I thought it was great and easy to use, but then I went to sort of evaluate my models and I couldn't find an AUC function anywhere. I think there was maybe one somewhere on GitHub that didn't quite work. So immediately I was like, okay, I see where this could go, but we're a long way away from having the maturity of some of these other languages. So despite that, I was able to still use Julia to do my research. So one of the things that I needed to do is that I developed a new method for constructing confidence intervals. And in order to prove that it was actually working, I needed to verify that. So I had to basically, there was 100,000 machine learning models that I needed to train quickly. I needed to create the data and then train the model, measure some metrics, and see whether or not the confidence interval actually contained like the real value that it was producing. So this was successful. I was able to fully use Julia for this, and I was just really not sure how I was going to do this in R with the state of the parallel situation at the time. So I probably could have done it in R if I was forced to, but I think also I was excited to try something new. So anyway, I'm a huge fan of Julia. I haven't been using it consistently over the past, 8 or 9 years. I've, gotten a job and basically am sort of required to use R and Python mostly every day. So I would love to have an excuse to use it more often though. All right, so that's kind of like where I'm coming from. So I just want to talk a little bit about what I call the language wars. That's not my term. I'm sure other people have used that term as well. It's just kind of this thing that happened, I would say, in the 2010s, kind of as data science is gaining popularity. There started to be this like, R versus Python, lots of blog posts, everybody has an opinion. It's a very binary thinking, which I think is just very outdated in all aspects. But I want to sort of introduce this as like a warning to like, let's not end up doing some of this stuff with Julia, because I think, and I haven't seen a lot of it. I have seen some benchmarks that's benchmarks are useful, benchmarks are important, but it's not, I just don't want to see a whole another decade of like, Julia versus Python, this and that. There's room for everybody really. And I think it's just kind of like a waste of time to have these discussions. So, sometimes you do have to make a choice. Let's say you're a new data scientist, you're trying to figure out what are you going to do. What are you going to learn? You have to learn probably one language first. It does make sense when you're a new data scientist to kind of at least somewhat try to master one language before kind of moving on to another. And I think that is a valid question. What should you learn first? So maybe we could just keep the discussion to that type of helpful narrative. But there's some negative stuff going on back in the day. Just a lot of Python people making fun of the R language, which I think is just very juvenile, and a lot of the narratives about that weren't actually even correct. So they would say, "Oh, R is slow for this, and you can't productionize R." Like none of that is actually true. So anyway, it was just a big waste of time. So I think that sort of language wars kind of really focus on like the wrong things. So I think, this is kind of like my thesis of the talk. So what do I think is probably the most important thing when you're choosing a language or when you're, using a language every day? I think like, how easy it is to use the language, and that is a function of like what APIs are accessible and what they look like and how clean they are and how maintained they are and how extendable they are. And then also just the community, like what is it like to work with people in this community? Is it unpleasant? Are people not nice? Are people, not helpful? Or are, you feeling welcome? Do you feel like you want to every day, get back on your laptop and start working on, this new language? I think that those are the things that make much more of an impact on like your actual experience with that language. And I mentioned this already, but like, a lot of these narratives are built on sort of false information anyway. If you want to look more into some of these ideas, RStudio has a blog post. Actually, I was just informed that RStudio has a new name and they're no longer called RStudio anymore. But I made these slides before yesterday or before today, so we'll just call it RStudio for now. So yeah, I mean, a lot of these myths are not even true. It's sort of like, oh, you can't productionize this, or it's too complicated to have multiple languages in one setting. And I actually don't find that is true, and I think a lot of people don't as well. So I just kind of want to emphasize, you don't really need to pick one language. It's not really a competition. Obviously you can only type one language of code at a time, but you don't have to identify with one language. You don't have to be an R person or a Python person or a Julia person. You can be like all those things if you like. And I will also point out that most experienced data scientists know at least, a little bit of both. And I think that will also be the case in the future for Julia as well. I think, there will always be a use in knowing multiple languages. So another point I'll make is, in this modern era, in the 2020s, it's very easy to use multiple languages in a single data science stack. So that was a little bit harder back in the day, just getting environments to work properly and having all the version numbers match up and things like that. It used to be a little bit harder, but now it's really not that hard. And there's just, you don't need to, you kind of choose one or the other. So I would say like, let's just talk about, all the useful languages are Python, Julia. I'm focusing mostly on R and Python. Of course, there's many other languages, C++, Java, but because I'm a machine learning person, I'm just going to kind of narrow the focus and the scope to those as well. Okay, so next, let's talk about like interfaces. So what is an interface? So this is a slide from John Chambers' Use Our 2014 keynote. So if you're not familiar with John Chambers, he's the sort of main developer of the S language, which is the precursor to R, which I will explain on my next slide. But basically, he had kind of this idea, like, at the time, so this is like in 1976, he was using Fortran. So this is, a still very efficient language. Definitely not one of the most easy to use languages. The API is not intuitive and not easy to use. So he had this idea of making what he called an interface language. And it was just a way to abstract the code so that it was more user-friendly. And this is kind of his kind of original sketch. So he showed this in the talk as well. So this is really kind of one of the first instances of somebody saying, okay, we have this like very efficient code that's, optimized for certain things, but what could we do to make it easier? So let's wrap that language basically. So this is kind of his first sketch of what the interface language would be. And from that, he then created the S language. So that is, the precursor to R. So S was not open source. R is, and that's the main difference. But yeah, it's basically having most of the functions that it has most of the functions that were important in Fortran, that basically that he thought were important in Fortran. He made interfaces in S, and then that continued into R. And really, his goal was, as he states, to turn ideas into software quickly and faithfully. So that is, that's centered on the user experience. How do we do this more quickly? How do we make it a more pleasant experience? And if you haven't seen his talk, the link below will take you there. It's a very good talk. He's a very wise person who's seen a lot of development of languages over time, especially statistical languages. So then what about Python? So where did that come from? So this is, another sort of language we're focusing on today. So basically, as stated by Guido van Rossum, he's saying, really the goal was to make a language that was sort of readable in English. So that when you're reading code, you can actually understand it without, having to have massive number of comments to explain what each function does. And, primarily probably that would be a comparison to C++, which is not super readable in most cases. So, and he, this is a quote by him kind of describing how he decided to go about doing this. He says it was kind of just this hobby thing that he thought might be fun. And he was also involved in this language called ABC. It was an interface to, I can't remember what the acronym stands for off the top of my head, but basically he was involved in that language. He saw some of the limitations there, and then he kind of iterated on that and created Python. So let's move on to Julia. So there's a great blog post that explains exactly why Julia was created. So, and I think anybody who uses Julia is probably aware of some of the advantages and some of the features that as compared to like R or Python or C. So it's designed to be as fast as C with the dynamism of Ruby, like both interactive and compiled, general purpose. So that's, kind of to be like Python as well. Good for stats and math. That's to be like R. Distributed, they mentioned Hadoop in their blog post. So they really like, a lot of things kind of started off. So for example, R didn't start off to be a general purpose language. It started off to be an interface to, highly optimized Fortran code. Python started off as just a way to have a general purpose language that you could read. So, we all have, there's reasons why each of these languages are formed, and really like Julia and why they created it has probably one of the most comprehensive and compelling stories about why it was born. Because we all are aware of, there are some trade-offs that you have by using R or Python or C++. And Julia, the authors or the co-founders of Julia said they were greedy. They wanted it all. So that was their goal. And, I think even with very early versions of Julia, I think they have achieved that. So, yeah, I think this is a very, broad, important effort. And if it all does pan out, there's, a very compelling reason to use Julia for a lot of things, especially in my background in like the machine learning space or data science space. Okay, so let's talk about multi-language software stack. So this is like very common these days. And I'll just kind of highlight a couple of the interface packages. So these are the different ways that you can call one of these languages from another. There's probably some on here that I don't know about. I just was kind of searching online to see what came up. The R package for calling Julia, one of them is called XR Julia. That one's by John Chambers, so I would guess that one is pretty good. Julia Call, I think, was the first one in 2017. Julia Connector, I think, is 2019. I don't know when XR Julia came about, but yeah, I mean, I think people see, especially the R community, we've always been a community where we are wrapping around highly optimized, computation code like C++, C, or Fortran. So it's just very natural to think that R would become another interface to Julia. And I think that is great. In the machine learning world, so most packages these days are multi-language. So there's a lot of Python packages for machine learning, but of course most of them are the hardcore computations are not written in Python. They're written in C++ or something else. So for example, TensorFlow is primarily C++. It has a Python interface. And then also via RStudio, there's an R interface, same with Torch. Of course, scikit-learn is also mostly C++ when it comes down to like actually doing the computations. And then I'm just gonna mention H2O as well, because we also fit into that category. So H2O is actually written in Java and has Python, R, and Scala interface. So this is very common, and so if you are developing code in Julia, this is maybe something that you want to think about. Like, there is, I know, a lot of wrapping already of good packages in Julia, but I think there's always room for more. So I'll just mention, this is my one kind of H2O slide, because I obviously know this package better than any of the other ones. So just kind of a quick overview of what that is. So we have distributed multi-core and multi-node implementations of all the popular machine learning algorithms and AutoML. So primarily what I work on now is automatic machine learning, and I'm the creator of the H2O AutoML algorithm, and I've been working on that since about 2017. So quite a few years now. Everything's written in high performance Java. So people maybe sometimes think Java, hey, that's maybe slower than C++. Why did you choose that? They're really comparable in this case. Like one of the people that was the co-founder of H2O was the creator of the Java hotspot compiler, which is like a thing that basically makes Java very fast. So he really knew how to use Java in a way that made it equivalent in terms of speed to C++. So yeah, and I mentioned there's APIs in R, Python, and Scala, also Web GUI. And one of the unique things about H2O, as opposed to something like a scikit-learn, is it was originally designed to be like used in production by enterprises. So everything was focused from the very beginning on how do we deploy models and how do we make them fast in production. And it's meant to work in a distributed fashion as well, which is also something kind of missing from some of the other platforms. So one thing that I'll talk about real quick is like, how do you maintain multi-language APIs? Because obviously it's easier if you have one code base and you just have to work in one language. Everything is much easier. But the reality is that people want to have multiple APIs. So that's what you have to give the people. So when they ask. So there's kind of two ways I would say that this is done. So one is that you have kind of the core code base, like the main code base where all the computations are. And then you have an API, maybe in Python, for example, and then you manually kind of like, if you get a new function in the core or a new argument to one of your functions, you would have to then go into the Python API and manually add it in there. So that's one way. That's obviously a little bit easier to begin with, but a little bit harder, like long-term, to maintain. So I want to just kind of make you aware that there's other ways to do this. So like in H2O, we auto-generate the APIs, more or less. Not everything is auto-generated, but all the machine learning code is. So if we add a new parameter to an algorithm, we basically have a build process where it just builds the whole thing, and the APIs get built from scratch every time. It kind of checks to see, okay, what parameters belong to this algorithm. If I see a new one, we add it there, and it's much more easy to, especially if you're going to have more than one language as your additional API. Like if you have an R and a Python, it's just going to be a lot easier to put the extra effort up front to basically, write code that generates APIs. It's basically Python code that's like reading the Java code and then spitting out both R code and Python code. So that's just something to think about if you're starting to do this. And then there's different ways that you can kind of communicate between languages. In H2O, for example, we have kind of a Java runtime that's happening, where that's where all the data is, that's where all the computation's happening. And actually, there's just a REST server that gets that's initiated when you start H2O. And when you're typing in the R API or the Python API, you're just actually making REST calls that say, train the gradient boosting machine with this set of parameters and on this data set. And it's just all, just basically JSON just going back and forth. It's giving the instructions to Java. Java does the thing, and then it sends the information back. So there's no copying of data from like one format into another. Everything is just in one format. We have our own data frame construct, which is called an H2O frame. And then, basically R and Python are just accessing the data that way. There's other ways you could do it where you kind of actually translate the data from one type to another. Like maybe you have an R matrix and that gets translated to a NumPy array. And then when you're using it in Python, you have all the data types that you would have in Python versus the data types in R, and et cetera. So there's different ways to do it, and they all have different levels of efficiency. And this is just like me saying it would just be so wonderful to see more R and Python packages that use Julia as the core computation instead of C++ and Fortran. I just think that would be awesome. Okay. All right. So then let's just talk about like why I think APIs are so important towards the success of a language or a package. So a lot of times, this goes back to the blog posts, people always making blog posts about things that, don't really need to be blogged about. But like there's a lot of speed comparisons. So, how fast can you load a CSV file in R versus Python or Julia or whatever? So while I think that is useful information, I think it's just one piece of information that you would want to take into consideration when you're making a choice what language or package to use. So I think there's a lot of focus, like overly focus on speed as like the be all end all of like language superiority. And, there's, I'll just remind you, there's a lot of like machine learning packages, for example, that are kind of dead now, that were super fast, super efficient, but there was, the API kind of sucked, or maybe the community didn't really, evolve or whatnot. So, there's many, especially C++ packages for machine learning that kind of just, are a relic of the past because they did not embrace kind of what I think are the more important things of a package or a language, the API and the community. So some of the things that I would say are important to consider. So, how readable and extensible is this language or package? The concept of like how quickly can you get an idea into an implementation? So that was, of course, the original inspiration with John Chambers in R. What does the package ecosystem look like and the experience? Is it easy to create a package and upload it? There's criticisms of the R community and CRAN for that being such a kind of unhelpful, fun process. So, there's lots of things that are important. Visualization, I think both our Julia and Python all are, making, good progress in these areas. There's lots of visualization libraries already in Julia that are very similar to the R and Python, but also just the APIs of those visualization like functions. Let's, consider how easy it is to make visualizations. And then of course, documentation and help, that's all part of like community. I think all of that is important. If you can't get good help and you don't have nice people to talk to, then, that's no fun and nobody wants to use your package or your language. And then let's kind of move back quickly to kind of machine learning and, let's look at some of these popular packages. So let's look at scikit-learn, that's like definitely hands down the most popular Python machine learning library. Then we've got tidy models, also the most popular machine learning library in R. And then of course, I'm going to throw H2O in there just for fun because, that's my expertise again. So like, what are some of the things that you would consider? So how clean is the API? Is it one interface for all the algorithms? I mean, that's basically essential at this point. You need like a single interface. You don't want to have a different interface if you're using one algorithm or another. That's just like standard at this point. That didn't always used to be the case. Before scikit-learn came along, we had like, hundreds of different random, Python packages with different things that made it very difficult to do, real data science, which requires you to do lots of experiments with lots of different algorithms in a very organized manner. So, before tidy models, there was the caret package in R, which is also the kind of scikit-learn of R, where it has a consistent interface to all the like mess of our machine learning packages that exist outside of that. So that's really just, the bar at this point. And then like, what are the capabilities of actually doing the whole data science pipeline? So, data science isn't just training a machine learning model, it's processing the data, it's doing the data processing and the machine learning in a pipeline with correct validation strategies. It's doing visualizations after you get the models. It's all of that. So how can we sort of like, what is the scope of the library? It's not sort of good enough just to do machine learning and training. And then another thing that is important that's, I think was a goal with H2O from the beginning, to make it easy and efficient to productionize models. Both scikit-learn and tidy models are kind of coming at that as a sort of an afterthought, but I think there's been a lot of progress there. But really, like, you need to kind of think about that in advance. And so I think, like, with Julia, for example, we need to think about like what's the machine learning, what's the ML ops thing for Julia, and how do we make sure that if people can use all this stuff, that they can actually use it into production, because we want people to be using it in the real world. And then of course, documentation and community is important as well, again. And so, in Julia, we have MLJ as kind of the prominent sort of meta package for machine learning. So it's great that kind of, I don't know if there is, controversy of, should there be a different one or should there be more than one? But I do think it's good for the community if there's kind of one main API, like, and everything could be sort of based on that API, kind of in scikit-learn too. So we have scikit-learn the package, and then we have scikit-learn compatible, X, Y, and Z packages. And I think it really just makes everything easier if it's consistent. So again, this would be like good to kind of look at with MLJ, like making sure you're kind of ticking all the boxes there. So then I want to talk a little bit like, what do I think is more like modern machine learning? So, scikit-learn has been around for a long time. So we've already, reached that sort of point in evolution of the machine learning like tooling where we have a single interface. That was a huge step from not having one. And now I think we're kind of moving towards like okay, now we have all these tools to do machine learning. How do we make it like still a little bit easier? And so that's what I've been working on is AutoML. There's lots of AutoML libraries in Python, not so many in R, but definitely quite a few in Python. And like, what are some of the benefits of that? So we've got, we want to automatically train and evaluate models. That's kind of the obvious thing. Some side effects of that are like faster experimentation. So you don't have to write a whole bunch of code every time you're trying something new. You just basically use one line of code. That also helps with reproducibility if you just have, a single function versus a whole bunch of different ways that you can configure things together. It also lowers the barrier to entry for people that are, not familiar with every single machine learning algorithm and how to use them and how to tune them. And then I think, the baseline performance of AutoML tools is quite good at this point. So I think this is kind of a natural, future, like in Julia, if, you start thinking about how to do AutoML. Another thing I think is important and not to be overlooked is, we've spent a decade or more in the machine learning community of like getting really good software and like all this stuff to train models and to evaluate models. But we are kind of now seeing like some of these new ways to evaluate models pop up. So it's not just like how accurate is my model, it's how explainable is my model or how interpretable is my model, and like is my model fair on different subgroups of people when I'm training on data that represents populations. So there's little toolkits popping up here and there in Python, especially also in R. R has a lot of explainability tools, a few fairness tools, but everything is sort of like third-party independent. There's not like scikit-learn doesn't have an explainability toolkit or a fairness toolkit. There are ones that are compatible with the scikit-learn interface, but I think, and I think this is good for now. Like, I think all of this is still kind of in development and experimental. So I think it makes sense sort of, let's just go to the next slide. Like, I think it just kind of makes sense in terms of Julia, like for all of this stuff to kind of happen independently first. I think rather than like the MLJ team saying, okay, we're gonna make an AutoML algorithm and that's the AutoML algorithm. I think that's kind of the wrong approach. I think there should be multiple things that happen in that space, and then kind of make them all MLJ compatible, so that then at some point, maybe there is kind of a default one there or something. But AutoML isn't the same as like implementing a GBM where there's kind of like a few sort of correct ways to implement it. It's sort of an evolving thing that's always getting better over time. So we don't want to ever say like, this is the AutoML. We want it to be flexible and, staying up to date with research and stuff like that. So I think for now, it kind of makes sense for that to be kind of outside MLJ. I mean, I'm not in charge or making any decisions, just kind of giving my opinion. And then also, like, it would be great to see some explainability tools in Julia, and perhaps those exist and I don't know about them yet, but I think fairness is another thing, more visualizations that can help with explainability, and then just these other topics that I mentioned, like production deployment, ML ops, all of that. So all of that seems like good stuff to work on. All right, so lastly, I'm just gonna mention community. So I think I've said this kind of already, but I think community is probably one of the most, like, if not the most important aspect of the success of a language or software package. So by community, like, what does that mean? So that could mean like, what is the package ecosystem like? How easy is it to contribute to open source packages, or to get involved in contributing to either the core of the language or popular packages? What's the documentation and help, like even on Stack Overflow? What's the vibe? Are people mean? Are they not mean? Like, are there nice, like, Slack groups or Discord or discourse, or how is the how is the vibe, I guess, basically? Is it inclusive or not? Are there diverse voices being represented at all levels? So one issue that we have in the R community is that we now have like a lot of diversity in terms of the users, but there's still kind of an elite group of, mostly men who run kind of our core. And so that's kind of problematic. And it's a hard thing to unwind once it's been that way for a long time. So it's just a lot of work to kind of tack that on after the fact. So Julia's in a great position to like really make this important from the beginning and really get people involved in just in the core stuff, not just like random package X is created by, underrepresented person. It's really getting those people integrated into all levels, including the leadership of the language. Yeah, so, and I'll just mention 2 communities that I'm a part of. So I'm a co-founder of Our Ladies Global. There's, as of today, 88,000 members, 218 groups worldwide. And we are bigger than the R user group community actually at this point. So I think this is a really good use case to follow in Julia because, I would say that the community of R is really, really represented by Our Ladies Global, like or Our Ladies in general. They're really active in the community, so much that we have twice as many user groups as the regular R user groups at this point. And we only got started in 2016. So this little graph here is the number of chapters over time. So you'll see kind of this line in the middle. That's when we got together at the UseR conference in 2016 and said, like, let's make this group and like, we were hearing people wanting to start chapters, like let's support that and let's like make that happen. So after that, there's like really explosive growth like worldwide. And so, maybe I know there's a presentation about Julia gender inclusive today. So, maybe this can be the year where you guys, put yourselves out there and like, it's going to be explosive growth from there on. And I think that like, people in these underrepresented communities can do far more for your language than you like even expect. Because if you sort of accept us, we'll be so happy and that we'll do so much work to like make this successful. And I think that's what's happened with R in the past like 6 or 7 years is like really we have embraced that we have been given a seat at the table and we're really included, and it feels really good to put in all this work to make the language popular. And so I think that's like the best untapped resource that you have, I think, in any community is getting these people that, don't have alternatives. Maybe the C++ community is not that great. I'm not saying anything about it. I don't know. But like, if there's, if you're the community which is accepting these people the most, that's going to be, those are your advocates. So highly recommend like supporting Julia Gender Inclusive. Then I'm going to mention this other group that I started that's called Women in Machine Learning and Data Science. So this is language agnostic. It's just general, like basically diversity inclusion meetups for people interested in machine learning and data science. So this is another group that like Julia people could get involved with, and having meetups in here and kind of just promoting Julia, and I'm happy to facilitate that. And then of course, Julia Gender Inclusive, I have to have a slide on them. So they had their announcement in June 2021 that they are, here we are, and here's why we got formed, here's what we want to do. So some of the current activities that I've seen is there's, talks at JuliaCon and Birds of Feather at JuliaCon, and they're doing some online meetups. So maybe, they're just getting started. So like, here's some maybe ideas for the future. So of course it's still, a pandemic. So we're not doing a lot of, in-person meetups at this time. So, maybe when the time is right to kind of reach out to local groups and kind of establish like local chapters of this organization. I think right now everything is online, which makes total sense for now. But in the future, when there's more growth, and it really is fun to have like a global village of people, and you meet so many interesting people from all over the world. And then one thing I think Our Ladies does a great job of is like recording a lot of the content from the meetups and sharing it on YouTube. So even if you miss the meetup, like, capturing that content and like reusing it over and over, just sort of to promote the group. And, you're also giving free content, and it's, maybe try to make the effort to kind of capture this content that you're making and preserve it, and to kind of reuse it as much as you can. One thing that I don't know if they would be interested or not, but I think I know that Julia has like a discourse where a lot of the chat goes on. Might make sense to have a private chat space for Julia Gender Inclusive. I don't know if they have announced that or not, or if that's in the works. It's just kind of nice to have a private space where you can, be more open with, your feelings about things, your frustrations, because a lot of like, it's quite frustrating to be a minority in data science and machine learning, or in tech in general, or just in the world in general. So having people to share kind of like frustrations with too is important. And I think that's, something that's, it's a positive thing. You can connect and like work on how to improve, at least what you can do to improve the situation. And then also just really get involved in like the larger meetup community, and tell people about what you're doing, and have joint meetups, and kind of use some of the existing infrastructure to kind of bootstrap your own community. So this is kind of what I would say for like to-do list for community. Like, one other idea is kind of run workshops to onboard underrepresented folks into contributing to Julia projects and core. So Reshma over at Data Umbrella has done a number of Scikit-Learn workshops where she helps to get people contributing to Scikit-Learn, and this has been, very successful. So things like that. Maybe add Julia Inclusive to the community page. I see it's like maybe not one of the top level things on the page, maybe like make a whole, section for it on the page, and then just kind of make sure community is kind of a top level priority of the Julia language. And then I think everything will just kind of happen naturally. And I think, there's a really bright future for Julia. So I think that is it. And I guess we have probably about maybe 10 minutes for questions. So I will stop there.
Thank you, Dr. LeDell. I think we're going to move on to the Q&A. So for people who haven't asked their questions on the Pigeonhole link, I'll be looking at those, and in the green channel on Discord. So people can vote up and down on the questions. So I think I'm going to ask for the most top-rated question. When can we get an H2O.ai API in Julia?
Oh, I thought you'd never ask. I mean, we have definitely talked about it. I mean, at H2O a number of times. I mean, I don't know that we were gonna like develop one internally, but I think if there was interest to do kind of like an open source collaboration, like that would be awesome. We are doing more like third-party integrations. So I just, worked on the integration with H2O into tidy models. So that's kind of a new exciting thing that's been kind of 2 years in the, like we've been talking about it for at least 2 years. So now that that's sort of, check that off the list. Like I would love to do that. And if anybody is interested, let me know, because I don't think we're going to be able to do it at H2O and devote like H2O staff and resources to doing it unless a customer asks us to do it. That's how we prioritize things. But if there is an interest in either including it in one of the existing Julia like machine learning libraries, or just having its own interface, like definitely let me know. Especially like it would be awesome to get AutoML in Julia.
All right. Let me see if I missed anything on Discord. No, just a lot of people thanking you for the presentation. I enjoyed it a lot. I also want to give a quick shout out to the Julia Gender Inclusive, because they do host a private Slack that you mentioned. There is such a forum, and you can contact Xian or the Julia Gender Inclusive group to gain access to that. So they've done a lot of good work, and they will continue to do so. All right. I think I see the next question here. Given your community organizing experience, any suggestion on what the Julia community can do to? No, we already you talked quite a bit about that, but there was one thing that you did mention, which is the next question, which is, what are some ways that users of Julia can do to avoid the language wars? We obviously want Julia to say, Julia is great without saying bad things about other languages.
Yeah, I mean, that's a good question, because I mean, kind of in the founding of Julia, one of the goals is to like do all the things, sort of, and excel at all the things. So there's sort of a natural like, comparison to be made. But I don't know, I think it's like a healthy discussion to compare different, use cases. And I think I would say, just rather than making broad statements like Julia's better than R, Julia's better than Python, is say like, let's compare how Julia, machine learning compares to scikit-learn, and like, what are some of the pros and cons of, whatever. Because maybe if Julia in the future has the ability to kind of, outperform some of these existing frameworks or tools, like, it is still very immature in that way. So there are some drawbacks to using Julia for things right now at this point. And so just having those conversations and having them get updated over time and say, in the last 3 years, we've seen like a lot of progress in Julia doing X. And so now we think it's kind of on par with scikit-learn or whatever. Yeah, I mean, it's good to talk about these things. It's just, you shouldn't just try to like make, broad statements. Like, it's like saying, I don't know, I decide that like red wine is better than white wine, and like that is the end of the discussion, and like nobody ever has to have that discussion again. Like, it's just kind of a silly thing. So just, being having healthy, positive conversations, and not just keep the negativity out. And I think
at least being able to recognize, like, hey, like, R made a lot of crucial decisions, like having that or interfacing with Fortran was a very key design decision. Like, how did that shape that language, and like, how did they design around those constraints? Like, even if we don't share all of the goals, like knowing the problems they faced and how they try to get around them, like, that's also very useful knowledge, talking to people who are there and did cool stuff. Thank you very much, Dr. LeDell. It's been great to have you. We hope to still see you around. And whenever you want to learn about Julia here, we'd love to have you again.
Great. Thanks for having me.
All right.